Hello everybody. Today I would like to talk about the computational chemistry. And for a little about myself, my name is Lê Vũ Phúc and currently I am the PhD student at the Technology Hồ Chí Minh University, and I also a pharmacist. I hope this topic will be interesting and maybe explain clearly of the computational chemistry. If you have feel it's very good, please subscribe me in below. Um, Now we can try into the first slide of the computational chemistry. The first question: what does the term computational chemistry mean? Computational chemistry is branch of the chemistry and it's used the computer simulation and theoretical methods. And the purpose of the computational chemistry is understand and predict chemical phenomena. We use the techniques like the mathematical model, algorithms, quantum mechanics, molecular dynamics, and statistical mechanics. And the scope of this computational chemistry is analyze chemical system at atomic and molecular levels, and it allows in the drug design, material science, and environmental chemistry. The second question is what kind of the question can computational chemistry answer? Likely, this if you answer the molecular geometry, it means that we have the molecule and we need to know the shape of the molecule, so that's the bond length, angle, and the radius. The energy of the molecule in transition state. It means that it tells us the isomer is favored at the equilibrium and the transition state and reaction energy, how fast a reaction should go. The third is energy of the molecule in transition state. Sorry, it's the it is repeated of the above. Maybe I go past the next is IR, UV, and MER spectrum. They can be calculated if the molecule is unknown. Someone trying to make this know what to look for. You can compare the spectra between the experiment and the method you use to predict the spectra. And so that if the molecule we do not the IR over MER spectra, we can use the computer tool to read this of the spectra. The next is interaction of substrate with an enzymes. This is your last in the design, and we use the molecular dynamics a lot because some of the model of enzyme they have the huge of the atom, and it's very difficult to use the quantum chemistry to write it if we don't have a good computer system. So but we can use molecular dynamics and it's belong of the computational chemistry, and we can answer of the interaction of the substrate with an enzyme and the physical property of the substances. That you a lot of on the material, and we reduce a melting point of polymer depending on how well the molecule is fits together and how strong the force between them are. If we have a lot of the question, we can answer if we use the computational chemistry. And for this answer of the main the question about we use the tool. Is it the computer tool? We can set up and we can build on the computer. We can use the molecular mechanism. Molecular mechanism is featured by the bond and spring model of the molecule. The second is AB initial methods. It is based on the approximate solution of Schrodinger equation without a pair of 15 experiments. We cannot compare with experiment of the initial methods. If we compare 15 to experiment, we will use the same empirical methods. And the next is the DFT method. Is the density function theory. It's based on approximate solution of Schrodinger also, but by bypassing the wave function. That is the central feature of the AB initial method and semi-empirical methods. I will do lately of the on of the tool we review in this series video, but in this video I just to introduce you for the method. And the last is the molecular dynamics method, study molecule in motion, and it can be used the Newton equation or you multi-cat law a molecular simulation of the bion multi-cat law, and I will go after this video. So in a theoretical AB initial and then the first DFT enable novel molecule of the theoretical interest to be studied, provided are not stupid. It means that we use field of the atom because we need to calculate a lot of the parameter of the Schrodinger equation. But when we use semi-empirical method, we will use the parameter from the experiment, and it can be very fast and it can be applied to a very large molecule. It means that we have a lot of parameter from experiment and we use it in our simulation, our calculation. So semi-empirical method is very faster than AB initial and DFT. And molecular mechanism we calculate geometry and the energy of very large molecule, so that is faster than the semi-empirical method, but it used just for the very large molecule, so that protein or nucleus is acid, but they don't give any information on electronic properties. And if you very limited of this method, because if you don't have some information of electronic property, maybe we can find some interesting of the property of the molecule. So we can be use the hybrid because we combine a bit initial molecule mechanism, or maybe use the DFT or molecular mechanism, combine them, and we have the very interesting information from this tool. But in the real time, we can use the supercomputer, and when we use supercomputer, even you can DFT or IP initial in the very large molecules such as the protein and nucleic acids also. The next is the one is computational chemistry useful in industry because nowadays is widely used in the pharmaceutical industry to explore the interaction of the potential drugs with the biomolecule. For example, by docking the candidate drug, it means screening of the candidate drug into the design of an enzyme, and it is also you investigate the property of a solid in the material science. We talk a little about the Schrodinger equation. The Schrodinger equation is used in the quantum chemistry, and it describes how the wave function of the system changes over time, and it features the same electron behavior of in the atom and molecule when we use the chemical, and we can use the Schrodinger to determine a low energy level and corresponding wave function for electron. And we can use for defining the electron structure, the range of the electron around atomic nucleus, because when the classical mechanism equation like Newton or the combined with when we use this classical theory to define the electron around atomic nucleus, it will be not exactly, and maybe we will be the answer. Thus, the molecule and the structure is not stable, and we need to use the quantum chemistry to understand some of the very weight property of the molecule and electron. And because the electron behavior is in the quantum field, and we need to use quantum chemistry to deploy them. But we have to some limits to solve the solution of Schrodinger equation because it's very complex. Schrodinger equation with the symbol system set of hydrogen will be easy to solve it, and we have the exact solution because we just have a one electron and one nucleus. But when the model is very complex, we cannot get the exactly solution because we have the interaction between the electron and electron, electron and nucleus, and electron and photon, and we cannot get the exactly of the Schrodinger equation. We we need to approximate of the solution of Schrodinger equation, and we use the compare to the experiment and use the numerical approach. It means that when we use the numerical methods to the chemical, we the computer they have the determined task. The computer the very good, the very strong power for such methods, such as numerical methods, and uh, in 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 this in when we use Schrodinger equation in the chemistry, the computer will come into the chemical because in the past the chemical don't need to the computer, don't need to the mathematical, don't need to algorithm. We just need to go to the lab in mix up the molecule, and so we have the result. If it is easy, if it do not have any mathematical, but when Schrodinger equation come when the quantum chemical is advanced, we need to the computer, and we need to the computer algorithm and the information in the chemistry. And we talk we talk a little about parameterization because when we use to the molecule in the computer, we need to reply to the computer what is the molecule, what is the hydrogen, what is the oxygen in what in this parameterization we come to reply of the molecule. In the parameterization we will use to sum up in to the Schrodinger equation to define of the electron, define of the nucleus, define of the charge of the electron, and of the kilo weight, something like that to for the computer to calculate in practice of the chemical properties. For that, if when the computational chemistry come to the chemical, it will show us with the cost effectiveness and now needs to very expensive lab. Experiment lab needs to a lot of the machine, a lot of the device, and it might be cost a hundreds of million of the dollar. And if we use the computational chemistry, we need just need a computer, just need a laptop to study, and everybody can study everywhere and do not need a lab. And speed, they very rapid calculation because if we use the high performance computer system, we can use very fast to get the result. It's better than the West chemistry. And sometimes the experiment and sometimes we can use to the we can use the West chemistry, but when we use the laptop and we use the tool, we can do the experiment on our laptop and get the result from that. And they get very fast and very relativity power. And maybe if we be complementary and to guarding the validation in when we do the experimental work. But the computational chemistry cannot replace with chemistry. The first the reason is accuracy limitation. We need to experiment to validate of the result of the computational chemistry. This means that we don't believe 100% to the computational chemistry. And um, some of the system we can unpredictable system, and we need to experiment to investigation start the semi calculation yield the parameter from the experiment in to destroy our model our model in when we use in the laptop in the tool, and it cannot replace out of waste chemistry. In some of the computational simulation it needs a lot of skill, and we need somebody understand of chemistry, understand how to code on the laptop, and it's not easy to get to clearly understand of chemistry and clearly of the algorithm in the programmer, and some of the competition developed in countries such as Vietnam. We do not have the first computer system to calculate a model very large, so that the one such biomolecule we need a supercomputer, and the supercomputer will cost really, and maybe we cannot access of the very super power of the computer, and it's the limitation of the computational chemistry. In some of the projects now, we will combine our computational experiment techniques, and so we cannot replace of the great chemistry. Thank you. This is on of the topics I would like to talk today. I hope this is very clearly when I show you what's the computational chemistry. If you have any question below, comment below of this video, and maybe please subscribe me and like me this video for me. Now, thank you. Goodbye. See you later.